Quite a challenging Barvember problem today. A shop sells computers and tablets. There are 462 items in total. A third of the computers are sold, a seventh of the tablets are sold, and 102 items are sold in total. And we're asked what was the ratio of computers to tablets at the start. Now, as I said, it's quite a challenging question. It's one that one would normally use simultaneous equations to solve. And the reason that well, actually, it makes a very neat bar model that actually it's easy to solve, but there are some things that you need to bear in mind that are quite different to some of the other problems that you may have tackled. Right, so we're told that there are 462 items in total. That's fine. So we know that the computers, the bar for the computers, we're going to divide into three equal parts because that is how they're dealt with here. And the tablets, we're told a seventh of those are sold. So we're going to divide that bar into seven equal parts. But often in problems, we're told how these might relate to each other. You might be told something like there are half as many computers as tablets, or you're given some ratio or something like that. But we're not here. So we don't know how the number of computers relates to the number of tablets. So I'm going to draw a bar for each. Computers, tablets. I'm going to, there we go. This is the bar for the computers. And because we're told that a third are sold, I'm going to divide this into three equal parts. And then I'm going to draw a bar for the tablets. And again, we're told a seventh of those are sold. So I'm going to divide this into seven equal parts. And as the person drawing the model, I know that the size of this part does not relate to these, even though because I've used squared paper here, it looks like two of these match one of those. I know as the drawer, as the person using the model, they don't. Okay, so where are we? We know that there are 462 items in total. Okay, so I'm going to mark that in. So that whole model has a value of 462. And we're told that a third of the computers are sold. Okay, so we imagine, let's say that's, that a third of the computers are sold and a seventh of the tablets are sold, and that 102 items are sold in total. So we know that these two together equal 102. But as I said, we don't know how much of the 102 is represented by this, how much of the 102 is represented by this. And just because I've drawn them this way round, where I've made the parts for the tablets smaller, there's actually nothing that tells me that number would be smaller than that one. I just don't know. So what can I do? Well, what I'm going to do is redraw or draw another model. Okay, so we're going to go computers and tablets again, and I'm going to draw that one part that was sold. Okay, so that's the one third from here, and this is the seventh of tablets that was sold. And what do we know? We know that that had a value, or that represented 102. Okay. Right. Now, in fact, you know what? I might just shade that in yellow to show that those are those ones that I'm talking about. There we go. So those are the same ones there. Okay. So what can we do? We know that we like to use differences. We want to be able to put values here. But again, we can't, although we could work out the difference between 462 and 102, that would tell us the difference between here and between here and here. And we wouldn't know, again, how much of that difference to attribute to the difference in tablets or the difference in computers. So how could we get around that? Well, what we might do then is to think, well, what if we had sold two thirds of the computers and 2/7 of the tablets. Let's see, what does that do? So we're going to add another third of computers and another seventh of tablets. And what do we know? We know that those two also have a value of 102. So now my model represents 204. Okay, with those two pieces here. Okay, now let's have a look. Do I have what is the difference then between this model and this model? Well, that includes a third of computers and 5/7 of tablets. And again, I don't know, I wouldn't know how much value to put here and how much value to put here. So let's do it again. We're going to add another set of that we know the value of. So now we have the 3/3 of computers and 3/7 of tablets, and that's another 102. So we now have, this model is now worth 306. And we now, the difference, now we can see that the difference between this model and this model, I'm going to cross that out and cross that out. We now know that the difference between these two models is only made up by a quantity of tablets. So if we calculate 462, if we take away 306, we get 156. I'm going to go to another color just because I can. And what is that? What does 156 show us? Well, that's the difference between 3/7 of tablets and 7/7. Okay, because we can see how we've got all of the computers accounted for. So this is 156. And what does that relate to? 1, 2, 3, 4/7, 4 parts. So we need to divide 156. We need to divide that by 4, which gives us 39. So now we know that each of these parts here has a value of 39. I don't need to write them all in, but it just looks good. There we go. I've got all of that value accounted for. So now what do we need to work out? We're doing a lot of calculations here. We need to go back and make sure that we know what we're asked. What was the ratio of computers to tablets? That means we need to know at the start, that's this model here. That means we need to know how many computers there were and how many tablets there were. So how do we work that out? Well, we know that the number of tablets is going to be 39 times 7, which is 273. So this equals 273. And what do we know then about the computers? Well, we can now see that we did know the total value. So if we take away 273, we're going to get the number of computers, which is 189. So this is 189. So we now know how many computers and tablets there were at the start. Now let's go over to here where we need to write our answer. So the ratio of computers to tablets, so we're going to write it that way around. So computers is 189 to tablets, that's 273. And then you need to think, could you simplify that in any way? What's the highest common factor that you could divide these two by? That happens to be 21. So I'm going to divide by 21. divide by 21, which is going to lead me to a final answer of 9 to 13. That is our final answer.